The distinction between storable and permanent pools is important for electrical safety, particularly when it comes to grounding and bonding requirements. A storable pool is generally characterized by its ability to be easily disassembled and removed from its location. These pools typically have a metal frame or sidewalls made of plastic or canvas. Storable pools usually have a smaller capacity, generally less than 500 gallons, and they are not permanently attached to the ground or connected to plumbing systems. On the other hand, a permanent pool is designed for long-term use and cannot be easily removed. These pools typically have a concrete fiberglass or vinyl liner shell and have a large capacity, typically over 500 gallons. Permanent pools are permanently attached to the ground and connected to plumbing systems. The National Electrical Code, known as the NEC, and local building codes provide guidelines for the electrical safety of swimming pools. NEC Article 680 covers the electrical requirements for swimming pools, spas, and hot tubs. Local building codes may have additional requirements for pool construction and bonding, including specific provisions for storable and permanent pools. While the NEC does not explicitly define storable pools, it does provide guidance in Section 680.2 D1, which states that storable pools shall be grounded by connection to the grounding electrode system. Furthermore, Section 680.2 D2 specifies that the grounding conductor shall be no smaller than AWG number 8 copper or AWG number 6 aluminum. These requirements indicate that storable pools must have a continuous grounding system. However, they do not specify the method of bonding or the need for continuity between pool sections. Based on these criteria, determining whether a particular pool meets the definition of a storable pool can be challenging. It often requires a comprehensive understanding of both the NEC and local regulations. Firstly, consider the ease of disassembly. Can the pool be taken apart and moved relatively easily without specialized tools or significant effort? Secondly, examine the construction. Is the pool made of lightweight material such as plastic or canvas supported by a metal frame? Thirdly, check the pool's capacity. Is it less than 500 gallons? Finally, assess whether the pool is permanently attached to the ground or connected to a plumbing system. If the answer to all these questions is yes, the pool is more likely to be classified as a storable pool. However, it is important to remember that the final determination rests with the local authority having jurisdiction. Regarding grounding and bonding requirements, all metal parts of a swimming pool, including the metal frame, metal parts of the pump motor, and metal parts of electrical equipment associated with the pool, must be bonded together to form a continuous electrical path. This bonding helps to minimize the risk of electric shock by ensuring that all metal parts are at the same electrical potential. For storable pools, the NEC requires a grounding electrode system connection. This means that the pool must be connected to a grounding electrode, such as a ground rod or the metal frame of the building. The grounding conductor must be sized according to NEC Table 250.122, based on the size of the circuit conductors supplying the pool equipment. For permanent pools, the NEC requires additional bonding requirements. These requirements include bonding the pool reinforcing steel, the perimeter of the pool, and all metal parts within 5 feet of the pool. The bonding conductor must be solid copper and sized according to NEC Table 250.66. Understanding the specific requirements for storable and permanent pools is critical for ensuring electrical safety. Ignoring these requirements can create a significant risk of electric shock, which can be fatal. It is always recommended to consult with a qualified electrician who is familiar with the NEC and local building codes before installing or modifying any electrical equipment associated with a swimming pool. The electrician can assess the specific characteristics of the pool and determine the appropriate grounding and bonding methods. When evaluating the continuity between pool sections, it's important to understand the purpose of bonding. Bonding is intended to create an equipotential plane around the pool, reducing the risk of voltage differences that could cause electric shock. If there is no continuity between the sections of the pool structure, this equipotential plane may not be effectively established. This is particularly important for permanent pools where the pool structure is often made of multiple sections of metal or concrete. In these cases, it is necessary to bond the sections together to ensure electrical continuity. For storable pools, the need for continuity between sections may be less critical, as the pool structure is typically made of non-conductive materials such as plastic or canvas. However, it is still important to bond any metal parts of the pool, such as the metal frame, to ensure that they are at the same electrical potential. The lack of continuity between the top and bottom tracks of the pool is a concern because it suggests that the bonding system is not effectively creating an equipotential plane. This could create a risk of voltage differences that could cause electric shock. It is recommended to consult with a qualified electrician to assess the bonding system and determine whether it meets the requirements of the NEC and local building codes. The electrician may recommend additional bonding measures to ensure electrical continuity between the pool sections. Regarding the use of beaver tooth lugs with stainless steel hardware, it is important to ensure that these connectors are listed and labeled for the intended application. The NEC requires that all electrical equipment be listed and labeled by a qualified testing laboratory, such as Underwriters Laboratories or ETL. This listing ensures that the equipment has been tested and found to be safe for its intended use. Additionally, it is important to ensure that the connectors are properly installed according to the manufacturer's instructions. This includes using the correct torque when tightening the connectors and ensuring that the conductors are properly inserted into the connectors. Stainless steel hardware is generally a good choice for pool applications because it is resistant to corrosion. However, it is important to ensure that the stainless steel hardware is compatible with the other materials used in the bonding system, such as the copper conductors. Galvanic corrosion can occur when dissimilar metals are in contact with each other in the presence of an electrolyte, such as water. This corrosion can degrade the metal and reduce the effectiveness of the bonding system. To prevent galvanic corrosion, it is important to use compatible materials or to isolate the dissimilar metals from each other. For example, you can use a dielectric fitting to separate the stainless steel hardware from the copper conductors. The fact that the AHA initially approved the installation does not necessarily mean that it is fully compliant with the NEC and local building codes. The AHA may not have been aware of the lack of continuity between the pool sections, or they may have interpreted the requirements differently. It is always the responsibility of the installer to ensure that the installation meets all applicable requirements. The discovery of the lack of continuity after the pool was filled with water highlights the importance of thorough testing and inspection. Before filling the pool with water, it is recommended to test the bonding system to ensure that there is continuity between all metal parts. This can be done using a multimeter to measure the resistance between the different metal parts. The resistance should be very low, typically less than 1 ohm. If the resistance is high, it indicates that there is a break in the bonding system and that additional bonding measures are needed. In conclusion, determining whether a pool is classified as storable or permanent requires careful consideration of several factors, including the ease of disassembly, the construction materials, the capacity, and the attachment to the ground or plumbing system. It is essential to understand and comply with the grounding and bonding requirements of the NEC and local building codes to ensure electrical safety. Consulting with a qualified electrician is highly recommended to assess the specific characteristics of the pool and determine the appropriate grounding and bonding methods. Regular testing and inspection of the bonded system are also critical to ensure that it is functioning properly and providing adequate protection against electric shock. Remember that electrical safety is paramount, and any doubts or uncertainties should be addressed by a qualified professional. Understanding these principles and applying them diligently will help to ensure a safe and enjoyable swimming pool experience. Consider these additional points for clarity. Firstly, verify the local definition. Contact your local building department or electrical inspector to determine how they define storable versus permanent pools. Local interpretations can vary. Secondly, document everything. Keep records of all inspections, permits, and electrical work performed on the pool. This documentation can be helpful if questions arise in the future. Thirdly, consider a pool inspection. Hire a qualified pool inspector to evaluate the pool's construction, electrical system, and safety features. A pool inspection can identify potential problems and ensure compliance with applicable codes. Fourthly, review the NEC definitions. While the NEC doesn't explicitly define storable pool, carefully review Article 680 for requirements related to all types of pools. This will provide a solid foundation for understanding the code's intent. Fifthly, focus on safety first. If there is any doubt about the safety of the pool's electrical system, take immediate action to correct the problem. This may involve hiring an electrician to make repairs or upgrades. Sixthly, educate yourself. Take the time to learn about pool safety and electrical codes. This knowledge will help you to make informed decisions about the pool and its operation. Seventhly, check the equipment listings. Ensure that all electrical equipment associated with the pool, such as pumps and filters, is properly listed and labeled by a qualified testing laboratory. Eighthly, use the correct wiring methods. Use only approved wiring methods for pool applications, such as rigid metal conduit or electrical metallic tubing. These wiring methods provide protection against physical damage and corrosion. Ninthly, protect against ground faults. Install ground fault circuit interrupters, known as GFCIs, on all electrical circuits that supply power to the pool equipment. GFCIs can help to prevent electric shock by detecting and interrupting ground faults. Tenthly, maintain the bonding system. Regularly inspect the bonding system for corrosion or damage. Repair or replace any damaged components to ensure that the bonding system is functioning properly. 11thly, use a qualified electrician. Always use a qualified electrician for any electrical work associated with the pool. An electrician has the knowledge and experience to perform the work safely and in accordance with applicable codes. These considerations will help ensure that the pool is safe and compliant with applicable regulations.